Hello guys, my name is Desmond and I welcome you to my YouTube channel. So ladies and gentlemen, for today's lesson we'll be looking at question 8 of 2015 exam paper, and this lesson is suitable for grade 10, 11 and grade 12 learners. Again, if you're upgrading physical sciences, you're also welcome to join our lesson for today. So ladies and gentlemen, I'm well aware that you do enjoy this chapter. It might not be that much difficult or complicated, but for today's lesson, I'm going to invest much of my time into making sure that you fully understand and visualize what is going on as far as electrostatics is concerned. Okay, very much important, ladies and gentlemen. Please make sure that by the end of this lesson you fully understand what's going on. Okay, so we've got a question there, we're given a statement. As you can see, we are also given a diagram of which I've tried to draw by hand there. Okay, very much important, guys. At all times, make sure to read the given statement, because that's where you find a very useful information. At some instances, you might even find some instructions in the given statement. Okay, so the statement reads as follows: two charged particles, charge 1 and charge 2, are placed 0.4 meters apart along a straight line. Okay, the charge on Q1 is positive 2 by 10 to the exponent negative 5 coulombs. That positive is very much important, guys. And the charge on Q2 is negative 8 by 10 to the exponent negative 6 coulombs. Point X, it's 0.25 meters east of Q1 as shown in the diagram below. You're also given a compass there. Ladies and gentlemen, very much important. So you should be able to draw all of this by just referring to that given statement. So what I'm trying to say is, if you were not given this diagram, you should be able to draw that diagram. So that's what they do at tertiary level. They just give you all of that statement and you should be able to visualize something similar to this. Okay, very much important, ladies and gentlemen. Please make sure that out of this lesson you learn something new. Okay, I've just remembered that I've told myself that in every video, I think it's very much important that I say it's very much important, because what I'm about to say, ladies and gentlemen, is very much important. Okay, a day without learning something new, it's a day wasted. Okay, please make sure that you learn something new out of this lesson. As I always say, my lessons are not only about teaching you or giving you answers to questions, but instead to expand your knowledge, okay, to help you with a broad perspective when it comes to approaching this type of questions. Okay, not necessarily this type, but a lot of questions that I do, I help you in terms of approach. Most importantly, start on a new page. Okay, so in your exams at all times, you're advised to start a new question on a new page. Ladies and gentlemen, let's now have a look at our diagram. Can you see what we're given? We've got charge 1, we've got charge 2, we've got 2 charges. Okay, as far as electrostatics are concerned, ladies and gentlemen, you are mostly interested in the value or the magnitude of the charge, or the charges if there are 2, and again the distance in between the 2 charges. Only if you can know those 2, then you're ready to go. Okay, so in this case you can see we've got charge 1, charge 2, we've got distance in between. Okay, and you're also given a point X, which is 0.25 east of Q1. That means it's very, very much important for you to understand this compass, to say top, north, bottom, south, to the right, east, to the left, west. Very, very much important, ladies and gentlemen. So when they say point X is 0.25 meters west of Q1, so that means you should know from Q1 you move by 0.25 to the right, as you can see there. All right, so otherwise it's again very much important that you know the distance from Q2 to point X. Okay, obviously for you to know that distance, we can just quickly indicate it there. Let me just use this marking pen. Okay, so the distance that I'm talking about, it's that distance from point X up to that charge there. Okay, it's very, very much easy to calculate that distance, ladies and gentlemen, nothing complicated. So you know the total distance, it's 0.4 meters. Then you know you've got this distance, which is that one of 0.25. That means that the remaining distance is the difference between these two. So 0.4 minus 0.25, it should give you the distance 0.4 minus 0.25. I'm not sure if you're able to see, guys, but let me just put it here so that you're able to see. 0.4 minus 0.25 gives me a 0.15. Okay, 0.15 meters. So that means that distance there is 0.15 meters. So the reason why I calculated that distance is because I wanted to say something in terms of the distance with regards to point X. Okay, remember, guys, you may be given information which refers to one and the same thing but in different manners. Okay, so now for those who are not doing geography, for those who do not understand compass, ladies and gentlemen, you just need to know that to the left it's west, to the right it's east, to the right, to the left of what? Ladies and gentlemen, your reference point will be either Q2 charge or Q1. Okay, so anything on the right side of that Q2, it's east. Anything on the left side of that Q2, it's west. Top is north, bottom is south. Okay, in most cases we deal with west and east, especially when it comes to this chapter. Okay, so to the right side of that point X, it's east. To the left side of that point X, it's west. Okay, so ladies and gentlemen, to the right side of that Q1, it's east. To the left side of that Q1, it's west. Okay, I hope we are now on the same page. Okay, very, very much important, ladies and gentlemen. You will understand shortly why it's very much important that you understand that compass. Okay, so I am going to give you this best strategy. I regard this as a best strategy because I've been using it since high school. I'm still using it now. It's been working, it's still working, and you know, I'm satisfied with this strategy. Ladies and gentlemen, I've always regarded a positive charge as a fan. Okay, I'm not sure this is the correct spelling for fan, but I assume it's a fan. So this is that fan that blows some fresh air or fresh wind. Okay, so this fan, guys, what does it do? You know very well that a fan blows some fresh air or wind away from itself. Okay, it doesn't really matter whether it's wind or air, but you know, whatever that it's blowing it away from itself. Okay, so let's say away. Okay, so ladies and gentlemen, I've always regarded negative charge as a vacuum. Not sure if you guys, this should be the correct spelling, but let's just say a vacuum. Okay, if there's what we call a vacuum. Remember, a fan is a device. You all know what is a fan, isn't it? Ladies and gentlemen, you know a vacuumer is a device, isn't it? You all know that fan and a vacuumer, those are the tools that we use, and they perform the opposite function. Okay, so obviously we know a vacuumer, what it does is to suck some air. Okay, so it's trying to draw some air. Otherwise, in short, it's actually pulling some air towards itself. Okay, that's what a vacuumer does. I'm sure you noticed when they clean some cars at car wash, they normally use a vacuumer. So what it does, it's actually drawing or pulling the air towards itself. Because of its power, it's then pulling some particles which could be in the car. Okay, very, very much important, towards itself. Towards itself. You will shortly understand what I'm trying to explain to you here, ladies and gentlemen. Okay, very, very much important. Let's say we've got a point charge which is positive. Okay, just like Q1 there, right? It's positive, isn't it? So, ladies and gentlemen, because we've got a point charge, you know, this story of a fan and a vacuum, it helped me a lot in terms of easily being able to draw these electric field lines. Okay, very, very much important, guys. In terms of the arrows, you know we use the arrows to indicate electric field around a point charge or a charge. Okay, so in this case, we're considering a positively charged particle or object. Okay, so ladies and gentlemen, we are saying a fan which is positive, it blows some wind away from it. Okay, so obviously because it's blowing some wind away from it, then this is a, if this is that positive fan, then we've got an arrow which is indicating away from that positive point charge. Okay, so obviously that will mean with regards to a vacuumer, it's going to point towards the vacuumer. Okay, you'll obviously realize that if this is a fan, it's going to blow wind away from it. That's why we indicate by means of arrow to say it's away from that point charge. Okay, so now with regards to a vacuumer, it's actually pulling some air towards itself. Okay, very, very much important, guys. I think you now have an idea of where I'm going. Okay, so ladies and gentlemen, we've got a positive charge. When I think of a positive charge, I know it's a fan. Okay, it's pushing away from itself. Remember, it doesn't really matter in terms of which word you use there. It could be pushing, could be away. So that means also there you can use a towards or any synonym of towards. Okay, so I just chose to use those two opposite words. Okay, so ladies and gentlemen, now let's say for some reason, remember this is a fan. Okay, this is a fan. Okay, because this is a fan, let's try to place a sponge somewhere there. Okay, just a small sponge. Okay, remember guys, I've just indicated that the amount or the magnitude of that positive point charge, it's very, very much important as much as the distance is important. What distance, ladies and gentlemen? The distance between the charge, which is a fan in this case, and a sponge in this case. Okay, the distance in between is very, very much important. Remember, it doesn't necessarily mean that at all times it's a sponge. It could be anything. Okay, you can put, let's say, maybe a feather there, or anything which is light in terms of weight. Okay, then let's say maybe it's 0.3 meters away from that charge, which is 0.3 you know east of charge 1, which is positive. Okay, so this could be maybe, let's just say, 10 by 10 to the power negative 6 coulombs. Okay, remember, very, very much important, guys. Positive value there. So ladies and gentlemen, a question is, there are some questions. I'll just explain to you those questions shortly. Okay, it could be electrostatic force experienced by that sponge there. It could be a electric field at that point there that we might calculate in relation to that positive charge there. Okay, so in terms of the force, guys, let me just explain in terms of the force. Okay, so if we want to calculate the electrostatic force experienced at that point. Okay, so we want to know the amount of air which is being experienced by that point there. Remember, the air is pushing, or rather the fan is pushing the wind in that direction relative to that sponge there. Okay, so what will, the moment we turn this fan on, obviously it's going to blow some wind in that direction of this sponge. So that means this sponge is going to experience a certain force pushing it in that direction. Okay, so what we want to do now when we do these calculations, we want to know the amount of force experienced by that point charge when it's placed at 0.3 meters to the east of that charge. Okay, very, very much important, guys. Very, very much important that you understand this part. Okay, the opposite is the truth, ladies and gentlemen. I'm not sure if I should just try to quickly explain in terms of what a vacuumer will do. Okay, but let me just do a negative charge, which is a charge Q2. Let's just refer to charge Q2. So obviously, we've got electric field lines around that charge. Okay, so obviously, guys, what does a vacuumer do? Okay, it's pulling it's sucking some air towards itself. Okay, so this is how you do the arrows. Okay, very, very much important that you understand this part, guys. Very, very much important. The moment you fully understand this part, you're going to be able to confidently tackle any questions related to a point being placed at a particular point or on the side of one of the charges, and you'll know the direction in which your final answer should be. Ladies and gentlemen, we place that same sponge at that point, which is 0.3 meters to the east of a point or charge 2. Okay, so now, guys, this vacuumer, when we turn it on, this vacuumer, what's going to happen to this sponge, ladies and gentlemen? I've just given a practical example that they normally use a vacuumer to clean the inside of the car. What does a vacuumer does? What it does is to pull, or it sucks some particles which could be in the car. Okay, so that's why I'm saying at all times I've always been referring to a negative charge as a vacuumer and a positive charge as a fan. So obviously, because this one is sucking, that means it's going to push not necessarily to push, but to pull this sponge towards itself. Okay, very, very much important, guys. It's going to pull this towards itself. Okay, ladies and gentlemen, I hope you now understand what's going on. Let me just give you another scenario, guys. Please do make sure that you fully understand this part. Okay, remember, this is just in relation to a charge and a sponge placed at a distance from that particular charge. Okay, so we normally use this to calculate the force experienced by that uh, a sponge, a force experienced by that sponge. We just want to know that if you want to keep this sponge right there, okay, we want to know how much of force you should apply by keeping this sponge there without it having to move in that direction. Obviously, that means if this charge is is pushing this sponge, let's say by 10 Newton. Okay, so that means if you want to keep this thing right at that position, you should make sure that you fix it such that the strength of that sponge is also 10 Newton. In that way, it will only experience a force of 10 Newton, but it won't move in any of the directions. Okay, so this is the application of this chapter in real life. That's how you solve real life problems. You need to calculate the force experienced by this. Then you know if you can successfully calculate the force experienced by that sponge. So that means for you to keep it in place so that it doesn't blow, you need to make sure that it is fixed by that force of the same amount. Ladies and gentlemen, let me give you a practical example. Okay, as you drive along the way, it could be N1, it could be any a national road. Okay, on the side of the road you've got some advertising boards, isn't it? You've got some advertising billboards. Okay, so I'm not really sure. Okay, let me just say this is that board, and then it's fixed there on the ground, and it's also fixed there. So the advertisement is like that. Okay, so it's fixed. Okay, so ladies and gentlemen, we're actually looking it from the side. Okay, so we're actually looking it from the side. Let's say something like that. I'm not sure if you're able to see. It's something like this, and then this is the information on the billboard. Okay, I'm not sure if you're able to see, guys, but I assume you understand what I'm trying to say. So ladies and gentlemen, you know, obviously on the roads there's some wind blowing, isn't it? So what we do, we calculate the average amount of wind which could be blown in that particular area. Okay, so if we know the force or the maximum force that has ever blown around that area, then it serves as a guide for us to know the amount of foundations, the amount of strength, the amount of weldings needed by this billboard. Because in that way we know if we make it such that it's strong enough, even when that strong wind comes, it won't it won't be uprooted and fly on the road, which will cause some accidents. Okay, so that's what we're trying to avoid, ladies and gentlemen. It doesn't necessarily mean that this what I'm explaining it has to do with this chapter. I'm just trying to give you a practical example of why you might need to be able to calculate the force, not necessarily for this chapter. It could be momentum, work, energy, and power, whatever chapter that it is. It's very, very much important that you learn how to calculate those quantities. Okay, so I'm sure you fully understand, guys. I'm sure this example makes sense. You must know the amount of wind the force of that wind. In that way, you'll be able to know by how much whatever that you install along the road has to be strong, okay, to be strong enough not to be uprooted or fall away as a result of strong wind. Okay, very, very much important, ladies and gentlemen. So now I'm going to erase all of these. Then from there, I'm going to explain something to you with regards to electrostatic. What is it? It should be an electrostatic field strength experienced by a point. Ladies and gentlemen, let me just do something like this. Let me see, we've got positive on the left, positive there. So let me just make a negative here and a positive this side. But let me just put them closer to each other because I realize there's something that I also want to explain to you guys. So let me just put it there and put it there. Okay, so now this is negative charge, this is positive charge. Remember, this is now my fan, this is now my vacuum. Okay, so in terms of drawing the field lines, let me see, I can just draw something like that and then also draw something like that. Remember guys, this is just for the purpose of me being able to explain to you what's going on. Okay, so remember guys, positive away. Okay, a fan, it's blowing wind away from the fan. Okay, a vacuumer, it's pulling towards itself. It's pulling towards itself. Okay, so because these two things are closer to each other, ladies and gentlemen, so as I've indicated, the distance is very much important, and that distance is referred to as r. Okay, which could be the radius or something. So ladies and gentlemen, because these two are closer to each other, obviously as this is pushing, at the same time this is pulling. Okay, as this is pushing, this is pulling. Okay, as this is pushing, this is pulling. Ladies and gentlemen, very, very much important. We can even extend to make it like this. Okay, to say as this is pushing, this is pulling. Okay, very, very much important guys. So now let me just do this. I think let me just also add that one there and also add that one there and also do the same on this side. Okay, very, very much important guys. So now if you put, let's say what is it, let's say if you put that same sponge, okay, if you put that same sponge somewhere there, ladies and gentlemen, if you put that sponge somewhere there, which is a certain distance away from that positive charge, and obviously a distance away from that positive charge, let's say R1, R2. Okay, so when we want to calculate the electrostatic field, remember, let me just use the word the net electric field at that point, which could be point X. We know in our mind, let's think of it as a sponge. Due to the two charges, ladies and gentlemen, the net electric field at that sponge or at that point due to these 2-point charges, that's when we talk about by how much is this being pushed away from a positive point charge, and again, by how much is that same point X being pulled towards that Q. Can you see guys? I'm not sure if you actually fully understand what I'm trying to explain, because I'm sure if you have done a lot of previous questions, you realize that they can put a point charge there, they can also put it somewhere, let's say there, let's refer to it as y. They can also put another one somewhere there, and let's refer to it as z. Okay, very much important, guys. Depending on how the question is asked, they may want to know in which direction is this feather there or sponge there moving. Okay, so you just need to know in which direction is that arrow directed to. It's either it's away or towards. So you need to know if it's a fan or if it's a vacuum. Okay, ladies and gentlemen, I'm asking for your forgiveness if I'm confusing you. You might have understood this chapter in a different way, but I'm just showing you how I understood and interpreted this chapter, because I've never gone wrong with what I'm explaining to you now. So in case if you have some difficulties, you can just try to replay this video over and over again until you fully understand what I'm explaining to you now. We will shortly after this start with our first question and relate it to this information that I've given to you. So I hope it will make sense, guys. So remember, if now you've got a point charge there and you're asked in which direction it's moving, obviously it's on this side of the charge, and this charge is a positive charge, then it's obviously pushing it away. So that's when you use this compass. Remember, top it's north, east, west, and south. So you can say it's moving to the eastwards. Okay, westwards if it's to the west or to the left. Okay, very much important, guys. What about that one there? Obviously it's going to move to the right, which is being pulled towards that vacuum. Okay, very much important, guys. You just need to know exactly where that point charge is placed. The other thing that influences the direction in which that could be moving is the strength of these charges. Okay, let's say for example the strength of that charge, let's say it's 100, the strength of this charge is 2. Okay, so can you see, guys, in terms of comparisons, obviously 100, I think it's strong enough compared to that one of 2. So that means chances are, even if let's say maybe we talk about that point charge which is placed there on this side of that charge, so that means this charge or this fan is blowing a very strong wind, such that even if this vacuum is trying to suck it, it's failing, because the wind which is being blown by that fan is too strong, okay, and in that direction. So that means even if this is trying to suck it or to pull it, it's failing, because that wind, it's very strong in that direction. I'm not sure if you understand, guys. That's where the values of the charges comes in. Okay, so now without any waste of time, guys, let's now start with the business of the day. I've actually wanted to explain to you this information, guys. I assume you've learned something new, as I've indicated that a day without learning something new, it's a day wasted. Ladies and gentlemen, let's now start with our first question. Okay, the question says calculate the net electric field at point X due to the two charges. Ladies and gentlemen, very much important. In this case, you've got 2 point charges, 1, 2. Okay, so you just need to know what is the formula for calculating the net electric field. Okay, but without you having to refer to that net electric field, you just need to know what is the formula for calculating electric field. Okay, so here on this is electrostatics, this is where you choose your formulas. Okay, so here you're not given the formula for the net electric field, but you have the formula for electric field, which is that E there. Okay, very much important, guys. So the formula for calculating the electric field is E. It's equals to K charge over R squared. Okay, very, very much important, ladies and gentlemen. But now, how many charges have you got? You've got 2 charges. Okay, so that means that point X, it's experiencing electric field strength as a result of both of those charges. Okay, that's why the question said net. It's because they want you to calculate the electric field at point X as a result of these 2 charges. Okay, so that means is the electric field strength of that charge plus the electric field of the electric field strength of that charge. Why am I plusing? It's because they said net. What is net? Net is total. What is total? Total means you add. Ladies and gentlemen, very easy and straightforward. So that means the electric field strength, which is the net, it's equals to the electric field strength as a result of charge 1 plus the electric field strength as a result of charge 2. Okay, very, very much important, ladies and gentlemen. So now let's substitute. We can just expand that formula. We know it's K charge over R squared. Then you plus K charge over R squared. Let's now specify to say Q1 and Q2. Okay, so now remember guys, this K, it's constant. It's given to you. Let's just go and check the physics constant. Can you see physical constant? That K, it's 9.0 by 10 to the exponent 9. Okay, very, very much important, ladies and gentlemen. It's 9.0 by 10 to the exponent 9. Okay, and then what is the charge? Okay, I think we might need to refer to that statement to check what is charge 1. Okay, nothing is complicated here, guys. Charge 1 is positive 2 by 10 to the exponent negative 5. So it's positive 2 by 10 to the exponent negative 5 over remember, this is where you need R squared. Okay, very, very much important, guys. I'm just wondering if I'm going to have enough space there, but I'll see if everything can fit over R squared. So the R is that distance from charge 1, because remember, this is where we substitute the values of charge charge 1. So that distance from there up to there, it's 0.25. Okay, very much important, guys. Again, here it's 9 by 10 to the exponent 9. Okay, so this is where you substitute that constant, and here you substitute the charge, of which I know this charge is negative 8 by 10 to the exponent negative 6. It's negative 8 by 10 to the exponent negative 6. And what is the distance? The distance is 0.15. Okay, so you can punch all of this on a calculator and see how much you get. Okay, remember guys, if you don't have or if you are not able to see clearly, remember this question is posted on my Telegram channel. If you've got Telegram account, you can just search for solving exam papers. That's when you'll be able to access this question paper for free. I post high school question papers not only for the subjects that I treat, but for all the high school subject. To the exponent 9, you close, open 8 times 10 to the exponent negative 6, you close, then at the bottom is 0.15, you close, and then squared. Okay, very, very much important, guys. I'm getting this number. I'm not sure if you're also getting the same number. It's 608, then it's 1 2 3 4 zeros. Okay, then it's Newton per Coulomb. Ladies and gentlemen, very, very much important that you write the SI unit. And most importantly, remember, in physics, we've got something called vector quantity and scalar quantity. Okay, a vector quantity, it has the magnitude, this is the magnitude, and the direction. Okay, so in terms of the direction, it's more like we want to know. Remember, we've got a positive charge, we've got a negative charge, right? And this one is is pushing away, and this one is also pulling. Okay, so that means a point charge which is placed there is going to experience electric field strength in that way. And then what is the compass saying? It says in that direction is the east, this is the west. Okay, so that means you can say eastwards. Okay, eastwards. Otherwise, even if you say to the east, you also got it right. Ladies and gentlemen, very, very much important. But there's a way in which you can write this answer in scientific notation. Okay, this is how I do it. I just count from a zero, that last zero, and I'm going to stop on the first number. So let's see, it's 1, 2, 3, 4, 5. Okay, did you notice I've counted 5 times? So that means this will be, let me see, let me actually stop at the last number, 5, and then we've got 6 there. Okay, so that means this is going to be 6,08 times 10 to the exponent. How many times did I count? 1, 2, 3, 4, 5, 6. Then it's to the exponent 6 Newton per Coulomb. Okay, then eastwards or to the east. Ladies and gentlemen, this is how you score your full marks. Let's check how many. It's allocated 6 marks. So for you to get that final answer with a magnitude and a direction, you obviously got them. Guys, I hope you understood that part. This is that sponge. Okay, so it's being pulled, it's being pushed in that direction by that, is being pulled in that direction by this negative charge, which is a fan and a vacuum. Okay, very, very much important, guys. So we can just give you a mark for correct formula. We can just give you some marks for correct substitution. And again, where else? We can also give you some marks, ladies and gentlemen, for a correct substitutions of distances, and again final mark on your final answer, 2, 4, 6. So that's how you score the full marks for this question. Okay, so now let's move to the next question, guys. Very, very much easy, very, very much straightforward, and I assume you now fully understand now that I've explained it in that way. Okay, I've always wanted to explain this to you guys so that you are ready for your exams. 8.2. So let's check what the question says. The question says electrostatic force at a negative 2 by 10 to the exponent negative 9 charge will experience at point X. So they want you to calculate the electrostatic force that a negative 2 by 10 to the power negative 9 charge will experience at point X. Okay, so it's more like at that point X, they put a sponge of that strength. Okay, so very, very much easy and straightforward, guys. You just need to know what is the formula for calculating the force, because that's what the question wants you to calculate the force. Okay, so sorry guys, let me just quickly mute that. So unfortunately, I forgot to put it on silent so that we don't get any interruptions. I'll just call them back. Ladies and gentlemen, the question wants you to calculate the electrostatic force. Remember, you've just calculated the electric field strength, and they've just given you the charge. So this is the formula that you can use. Okay, very, very much important, guys. So it's E, it's equals to F over a charge. Okay, so let's make force the subject of the formula. You just multiply, then you remain with force, which is equals to EQ. Okay, ladies and gentlemen, you calculated the magnitude of that electrostatic force. If I remember very well, it was 6.08 by 10 to the exponent 6. And now they are saying that charge there, it's negative 2 by 10 to the exponent. Let me just quickly check what is the magnitude of that charge. It's negative 2 by 10 to the exponent negative 9 coulombs. Okay, very, very much important, guys. Let's now have a look. So when you substitute it there, it's 2 by 10 to the exponent negative 9 coulombs. Then you can just multiply the 2. Let me just say multiplied by, because I already had the answer, 2 times 10 to the exponent negative 9. Then I close. Let's see what answer I get. So I'm getting this number. I'm not sure if you're also getting the same number. 0.1216. Obviously, it's Newton because it's a force. And again, a force, it's a vector quantity. Okay, very, very much important, guys. So now the question is, in which direction will that point charge placed there be moving? Okay, so remember, guys, you've got that point charge there which was positive, that point charge there which was negative. Okay, so now what they do is to put a point charge there. Okay, very, very much important, which is a negative point charge. Okay, so now because this is a negative, remember, this is what happens, guys. So this is what happens, and then you've got this is what happens, and then you've got that, this is what happens there. So ladies and gentlemen, as you can see, remember there's that say which says same charges repel each other. So I think it could be the same scenario here where you've got these 2 point charges repelling with each other, which makes it that one to move, which makes it that negative point charge to move in that direction. Okay, so it moves that direction. It's more like it attracts with each other with that one there. Okay, so now that means this is the answer westwards. You can just say westwards or to the west. Okay, very, very much important, guys. So now let me show you how I write that in scientific notation. Then it's 1, 2. Okay, I think I can just stop there. Then that means it's going to be a 1.2. Let me just round it off. Then 2 times 10 to the exponent negative 2 Newton to the west. To the west. You write it nicely. So ladies and gentlemen, why negative there is because it's a decimal. So that means when you punch this, it should take you back to that. Okay, very, very much important, ladies and gentlemen. So now that means an answer to question 8.2, it's a 1.22. Okay, very, very much important, ladies and gentlemen. So now let's have a look at the last question. They say without any further calculations. Remember, guys, this question is allocated 4 marks. So for you to obviously get to that final answer, you score full marks. They can just give you a mark for either this or that formula. They give you a mark. Okay, and they also give you a mark for correct substitution, and a final mark comes from your final answer with the correct SI unit. Okay, and most importantly, to the west. So they say without any further calculations, determine the magnitude of the force that negative 4 by that charge will experience at point X. It's allocated 1 mark. Ladies and gentlemen, nothing complicated there. as you can see, remember that point charge, it was negative 2. So now they are making it 2 times more, which is now negative 4. It was negative 2. Can you see? Then it means it's just going to experience 2 times the force. Okay, very, very much easy and straightforward. So that's how you score your 1 mark, guys. Let me just erase this part up to there. So 8.3. So remember, when it was 2 by that, it's equals to this as the force. So now they increase it by another 2. So that means the force is going to be 4 by 10 to the exponent negative 2 Newton. Same direction. Okay. Very, very much important, guys. You shouldn't be confused by this type of questions. Just check the relationship between what you are given and what they are asking you about. So, guys, thanks very much for joining. I hope you enjoyed this lesson as much as I did. And I thank you very much. Please make sure that if you have watched this video until this far, make sure to subscribe, hit the bell notification to be notified of future uploads, and please do make sure that you refer some of your friends so that they can also benefit from these lessons. Okay, guys, my name is Desmond, and I'm out.